In this lesson, I'll show you how to graph a cosecant function. We obtain the graph of a cosecant function by taking the reciprocal of the y values in the graph of y is equal to sine x. Vertical asymptotes of y is equal to cosecant x occurs at the x-intercepts of y is equal to sine x. Now, if that's confusing to you, let's take a look at a table for a period of 2 pi for sine. Let's say we had sine alpha, our angle is alpha, and we assigned angles all the way to 2 pi. Notice that sine is at 0 when the angle is 0 and when the angle is pi. Now, according to what was said right here, if we take the reciprocal of 0, and by reciprocal I mean I flip the number and make it 1 over that number, I'll end up with 1 over 0. Now, you can't divide anything by 0, it's undefined. So at these points, this one and this one, specifically, you'll have asymptotes. Everything else will give you an output. A visual of what I just mentioned is shown right here. Notice that sine is this wave, and sine always starts at 0 and 0, makes its way up, back down to 0, goes to its minimum, and then the cycle starts again. At 0 and pi, you have these borders, which your other curve cannot pass. And those are our asymptotes. So in this particular example, what we will do is use the graph of y is equal to sine bracket x plus pi over 4 to obtain the graph of y is equal to cosecant x plus pi over 4. And this is how you always do it. You have to find out what it looks like as sine, and then keep in mind the asymptotes and the characteristics of cosecant when creating the sketch. So let's start by graphing sine x plus pi over 4. First, you want to identify your a, b, and c, because that will help us with knowing what the period is, amplitude, etc. Now the amplitude is 1, our b value is 1, and the b value can be related to the period, where period is equal to 2 pi over b. We have 2 pi over 1, our period is 2 pi. C is related to the phase shift, and we'll worry about that in a moment. Once you find your period, you want to divide this by 4. That will represent the 4 quadrants, and this gives us pi over 2. So I'll write down pi over 2 over here. Pi over 2 plus pi over 2 is pi, plus another pi over 2 is 3 pi over 2, and then we're back at 2 pi. This is what the sine looks like without a phase shift. Starts at 0 and 0, makes its way up. Let's call this 1. Down again. Let's call this -1. And back to 0. I'll connect these points with a curve. And now I'll apply my phase shift, which is pi over 4. That means we're being shifted to the left by pi over 4. Pi over 4 exists halfway between each of these quadrants, so it should be right around here. And since we're going to the left, this point will now be over here, this point will be over here, this point over here, this point midway right here, and this point right here. I'll connect these with another curve, and I'll erase the blue one for clarity. What you see in red is what the sine wave looks like when your c value is pi over 4. Now, using this, keep in mind that we're at 0 here, here, and here. So I'm going to put asymptotes where I have my zeros. Now that I've drawn those in, next I want you to take a look at the maximum and minimum values of our red wave here. The maximum occurs right here, and the minimum occurs right here. Let's go back to the table we started with, and let's see what the reciprocal of the outputs were at the quadrants, pi over 2 and 3 pi over 2. We already know what happens with these two quadrants. If I take a reciprocal of 1, I end up with 1. And taking a reciprocal of -1, I get -1. This means that I will also have points right here and right here for cosecant. If you take the reciprocals of these, you'll find out that these numbers will decrease to the minimum of 1 and then increase back again up until it reaches the asymptote. So I'll reduce this wave so that the amplitude 1 is over here and over here, just for clarity's sake. Let me show you what I mean. Now that I've done that, you can see that as we move to the right of this asymptote, the wave will reach its minimum point, and then start to increase beyond its minimum. Similarly, it will increase to the right of this asymptote, reach its maximum value where the minimum value of the sine function occurred, and then decrease once again. What you see in black represents cosecant for this exact same configuration as the sine. And there you have it. That is how to graph a cosecant function.